Hello Pre-Calc, my name is Mrs. Peterson, for those of you who don't know me. Today we're going to be looking at 4.1 Radian Measure. Before we get started, I want you to take a look at this checklist, make sure you're ready to go and ready to interact with the math. So make sure you've got your notebook open, something to write on. Make sure you've got one pencil and one pen or two different color pens. And that's for your regular pencil when you are taking notes and working with me. And then the other color, like a red pen or pencil, for when you are going to make any corrections, okay? Make sure that your cell phone is either put away or on airplane mode or do not disturb. And then make sure that your headphones are in so that you are fully engaged with the content. All right, let's get started. We're going to start with a warm-up. There will be times when I ask you to pause the screen, and there will be times when I do a forced pause on your screen. In this case, because there's quite a bit on the screen, I would like for you to pause and try this warm-up on your own, and then we will talk about it. All right, go ahead and pause. All right, here are the answers. So let's see how you did. The circumference of the whole circle will be 2 pi. Just the top half will be pi, and then half of that will be pi over 2, okay? And we're going to use this in just a bit, so hang tight to this information. All right, I'm going to ask you to pause your screen again, copy what is on my screen, and then we're going to fill it out together. All right, so hopefully you've copied the screen. Let's talk a bit about some vocab for angles. So when we're talking about an angle, you've got your initial side, which is going to be the positive x-axis there. Then you've got your terminal side, okay? And terminal, in other words, where it terminates or where your angle ends, okay? So then you've also got what we call the reference angle, okay? The reference angle in this picture is that little angle there, okay? So the formal definition of a reference angle, let's write this together. It's the acute angle made with the terminal side, and this is important, the x-axis. Okay, so let's say that this is a measure of 135 degrees. What would the reference angle be in this case? So the reference angle, this piece here, I can tell that's going to be 180 minus 135. So my reference angle here, that acute angle, is 45 degrees. Okay, we'll be using reference angles a lot for the days to come. One other note is if you are going to be measuring positive angles, like what we just did, notice that I rotated counterclockwise, right? And conversely, negative angles, if we want to go the other way, would be clockwise. Okay, so if I wanted to find negative 135 degrees, I would still start at that initial side, but go in the clockwise direction, okay? So this is negative 135 degrees. And if you notice something, notice that 135 and 135 are reflections about the x-axis, and you will continue to see that pattern as we do some more here. Okay. All right, so let's try an example together. Can you draw a little xy axis in your notes? And let's draw 210 in standard position and determine the quadrant where the angle lies as well as the reference angle. And just if you need a little reminder, remember we go quadrant 1, 2, 3, and 4. In other words, we go C for correct, right? Okay. All right, so 210 degrees, that's a positive angle. So again, I'm going to start at the positive x-axis and go counterclockwise. So I know this is 180, so I am going to need 30 more degrees here, so approximately there. So that's 210, okay? Then it says determine the quadrant. So I can tell it terminates or it ends in quadrant 3, right? And then we also want to know the reference angle. So remember that's the acute angle made with the terminal side and the x-axis. So that's going to be that piece there. So I can tell that 210 minus 180 in this case will give me my reference angle. So my reference angle here is 30 degrees. All right, okay, I'd like for you to pause the screen and try negative 210 for me this time. So go ahead and pause, try negative 210. All right, so I've got the answers on the screen for you. You can check your work and let us know how it went for you. All right, now we're going to talk about 2 units for measuring angles. So the unit of measure used in geometry was a degree, right? Especially in calculus, we've got another unit of measure we use much more frequently, and that's called a radian, okay? So before we get going on these, I'm going to force a pause on your screen and just ask you to copy what I have so far. Okay, so let's talk about these 2. First of all, you are used to lots of different units of measure, right? You can measure distance in miles or feet, and you have conversions for each, right? So similarly, we've got different ways to measure angles, and we're going to look at the conversion there as well. All right, so first of all, a degree. Well, what is a degree? So if I think of a degree, I think of a pretty small angle, okay? I know that a full rotation is going to be 360 degrees, correct? So a degree is 1/360th of a full rotation. Okay, when I look at that number, I think that that seems a little bit bizarre. But I want you to think about, like, where do we see a number very similar to that in nature, especially in time? So, like, how many days in the year approximately do we have? We've got 365 days. It takes approximately 365 days for the Earth to make a complete orbit or a complete rotation around the sun, right? And that's actually where this number comes from. So this number comes from the Babylonians, which is really amazing because they noticed that there's about 360 days in a full year. And they noticed this about 2,000 years ago. So yeah, they were off by a few days, but this was a really long time ago. Also, their system was base 60. So this worked quite nice for them. So that's where we get a degree. So it should be 1/365, but we've historically gone with the 1/360. Okay, so now let's take a look at what is 1 radian. Okay, so a radian, and I'd like for you to write this with me, is a central angle whose arc length is 1 radius. So you can see, hopefully you kind of heard that in the name, radian and radius, very similar, okay? So let's take a look at approximately how big is 1 radian. So take a look at this picture for me. Here's a radius, right? If I take that length and pull it along the circle, like right around there, that is the measure of 1 radian, okay? So let's see, can you picture where 2 radians would be? So if I take that same length and continue on, what do we think? Approximately there? And the 3rd radian is going to be approximately there. Do you see we've got a little bit more than 3 to get to half a rotation, right? Any idea approximately how many radians we're going to have to get to that full 360 degrees? Okay, so I'm going to show you a video and let's see if we can answer that question together. Okay, so here I've got a circle with radius 1. You can see that blue length of the radius there. I'm going to drag that length across the circle. So let's see here. All right, so here's 1 radius, right? So there's 1 radian. Let's drag another one. Here's the second one. You can see it kind of lands in the second quadrant there. So here's the 3rd one. We're not quite to half the rotation yet. We're at about 3.05. Any idea where I would need to be to make that half rotation? Any number we see a lot in math? Think about that. Okay, here comes the 4th radian. Okay, 5th radian, 6th radian. Okay, and you see we need just a little bit more to make that full rotation. And we're going to land right at around, you can see 6.28 is where we need to land. So what do we think? How many radians make a full rotation? It's going to be 2 pi, right? Half a rotation is going to be 1 pi. A full rotation, or 360 degrees, is going to equal 2 pi. Let's keep looking at this video. So if I make this circle bigger, here's still my 1st radian. There's my 2nd, there's my 3rd. Okay, and again, 2 pi to make that full rotation. It's independent of how big the circle is, right? We can go to a smaller radius. So here I'm going to do radius of 0.5, 1st radian, 2nd radian, 3rd radian, 4th radian, 5th radian, 6th, and 6.28 approximately. That is my 2 pi to get all the way around, okay? Okay, so how does this compare to that warm-up we did? Well, we just saw that a full rotation is going to be about how many radians, or how many of those radii do I have to take to stretch all the way across. So it was about 6. It was exactly 2 pi, which is 6.28 approximately, right? Half a rotation was a little bit more than 3. It was exactly pi, so 3.14. And just kind of so that you have this information, half of that is pi over 2, which is about 1.57. And then if I come here at 3 pi over 2, or 1.5 pi's, that's about 4.71. So remember that our 1st radian ended about here, which makes sense, right? Because I would need about 1.5 to get to that 90-degree mark. All right. Okay, so now we need a way to go between one unit to the other, just like you know there are 12 inches in 1 foot. We need to see, okay, how many degrees in a radian and vice versa, so we can convert from one unit to the next. So let's think about, let's do half a rotation. So in degrees, half a rotation is 180. Right? Now you saw, hopefully, that for radians, we need a little bit more than 3 lengths of the radius, right, to get halfway around. In fact, we needed exactly pi radians, right? So now if you divide both sides by 180, you would get that 1 degree is pi over 180 radians, okay? All right, so let's do this. Can you pause your screen and copy mine? Okay, so if I want to convert from degrees to radians, I'm going to multiply by pi over 180, right? If I want to go the other way around, if I want to go from radians to degrees, then I want to divide by pi over 180, or multiply by the reciprocal, right? So I'm going to put multiply by 180 over pi. Okay, I'm going to force a pause on your screen and ask you a question here. All right, so we've got one last definition, and that's coterminal angles. I'm going to force a pause on your screen and ask you to copy just this definition of a coterminal angle. Okay, so coterminal angles are 2 angles with the same terminal side. They coterminate, right? So they differ only by the number of full rotations it takes to get to the terminal side. So, for example, if I've got 70 degrees, to find a coterminal angle, I could take that 70 and do another full rotation, right? So if I'm in degrees, I'd have 70 degrees plus 360 degrees, in other words, 430 degrees, okay? But I don't have to go in the positive direction. We could do 70 degrees minus 360, right? So that would give me negative 290, okay? All right, so for coterminal angles, they are going to vary in degrees by plus or minus multiples of 360, okay? So let's write these together. I'm going to force a pause on your screen to copy mine, and then we'll fill in together. All right, so to find coterminal angles in degrees, I want to add or subtract multiples of a full rotation, which is going to be 360 degrees, right? Okay, so 360, 720, etc. For radians, though, how many radians make a full rotation? Remember, it was just over 6. It was 2 pi. So I'm going to add or subtract multiples of 2 pi. Okay? So that is all we have for today. I'm going to force a pause on your screen and ask you one last question, and then we'll pick up in class. Thank you.